In lesson 10.3, we talked about properties of arcs. This time we're going to talk about properties of chords. A chord divides a circle into two arcs. If the chord's a diameter, that's two semicircles. But if the chord's not a diameter, it divides it into a minor arc and a major arc. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if I have equal chords, then the minor arcs formed by those chords will be congruent. So arc AB is congruent to arc CD if and only if line segment AB is congruent to line segment CD. So in this diagram, I've got circle P and is congruent to circle Q. You can notice the radii are marked to be congruent. It says that arc FG is congruent to arc JK, and the measurement of JK is 80, so find the measurement of FG. Well, we just looked at a theorem that said that if the two chords are congruent, the minor arcs are congruent, and therefore it's equal to 80 degrees also. So a little guided practice. If the measure of AB is 110, so measure of arc AB is 110 degrees, find the measure of arc BC. So since the chords have the same length, the arcs have the same length, so 110. Excuse me. The next question says if AC from A to C is 150 degrees, then find simply from A to B. Well, I really can't do that if I don't realize that these two are the same. And so it comes out to be 105 degrees. Now, how did I get that? I said 360 minus 150 has to equal 2x. And so this gives me 210 degrees is 2x. That makes x 105. So we get 105 degrees, but you have to know that those two are equal to be able to get that. In a point, line, segment, or ray divides an arc into two arcs with equal measures, then it's said to bisect the arc. So we're just going back to the definition of bisector. We've talked about angle bisectors and segment bisectors, so now we're talking about the bisector of an arc. If a chord is perpendicular bisector of another chord, then the first chord is a diameter. Okay, let's think about what that's saying. If SQ is a perpendicular bisector to TR, then SQ has to be a diameter of the circle. Now, I don't know where the center is, but I know that SQ goes through the center. Theorem 10.5. It says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord in its arc. Now that should make sense. We just said that if one chord bisects another one, then the first chord must be a diameter. So if a diameter is perpendicular to a chord, then it's going to bisect the chord in its arc. If EG, line segment EG, is a diameter and line segment EG is perpendicular to DF, then line segment HD is congruent to line segment HF, and arc GD is congruent to arc GF. So let's look at how we would use these. 3 bushes are arranged in a garden as shown. Where should you place a sprinkler that is the same distance from each of those 3 bushes? So I want a sprinkler out here somewhere, and it's going to be a circular sprinkler, so I want it to hit all 3 of those bushes. So I want it to be the same distance from all 3. How would I do that? Well, I would label the bushes A, B, and C as shown and draw segment A, B, and BC. So what I'm doing is I'm saying, okay, I've got this circle coming around here that goes through all of them, and I just drew two chords. Now if I draw the perpendicular bisector of AB and BC, by theorem 10.4, both of those have to be diameters. And if those two are diameters, then the point where they meet has to be the center of the circle. And so if I place my sprinkler at that point, that has to give me a circle that will hit A, B, and C. So use the diagram of circle E to find the length of AC. Tell what theorem you use. Since FA is 7, that means that, and this is a diameter that is perpendicular to AC, that means it bisects AC, and therefore AC is 14. Find the measure of the indicated arc in the circle. This is your guided practice here, so give it a try. What I know is that measure of CD will come out to be 72 degrees. Now let's look at how we found that. Since BD is a diameter and it is perpendicular to CE, I know that BD bisects both the chord CE and the arcs that are formed. Therefore, what I know is that 9x is equal to 80 minus x. If I add x to both sides, I get 10x is equal to 80, and now x is 8, and so 9 times 8 is 72 degrees. Well, what about DE? Well, that would have to be 72 degrees also, because we said that it was equal to the other one. What about CE? Well, CE, arc CE is made up of CD and DE, so we add those two together and we get 144 degrees. Theorem 10.6. In the same circle or in congruent circles, two chords are congruent if and only if they were equidistant from the center. Now I want you to notice that for chord AB to be congruent to chord CD, then line segment EF has to have the same measure as line segment EG. And notice that they're measured along a perpendicular. Remember, we always measure from a point to a line along a segment that is perpendicular to the line. In this diagram, I've got circle C. It says that QR is congruent to ST, and they're both 16. So find the distance from CU. Find the distance from C to U. Now what we have is two congruent segments, and so if they're congruent segments, they must be equidistant from the center, and therefore I can set them 2x equal to 5x minus 9. Simply solve the equation. X is 3, and so if I plug in, I can see that CU is 6. A little guided practice here. Two of these are pretty straightforward, and one of them is going to require you to think a little bit. So give them a try and see what you come up with. QR. If CU is 12 and CV is 12, then QR must be the same as ST, and that is 32. That makes QU 16, because if I drew from here through, I would have a diameter that is perpendicular, therefore that has been bisected, and therefore it's half of the 32. Now the radius of C is the one that I said may have been a little more difficult. Let's see if you got it right. The radius comes out to be 20. Now how did we find that distance from here all the way out to here when I only know part of that segment? Well, what I know is that this is a radius too, from C to R, and so I have a right triangle. I know one side is 12, this other side is 16, So I can use Pythagorean theorem. CR is going to be equal to the square root of 16 squared plus 12 squared, which comes out to be 20.